So the plan going forward is obviously launch a bunch of partner wines, hopefully make any remaining mistakes that we would make on the Falcon wine, and so that we make no mistakes with Falcon 9. And the first Falcon 9 launch is intended to be sometime next year. I'd say probably sometime in the second quarter-ish. So we do expect to have Falcon 9 at Vandenberg by the end of the year, although we're going to finish all the qualification tests. I think we'll probably finish the first stage, but not necessarily the rest of the vehicle. We will have a fully assembled vehicle at the Cape by the end of the year. And then Falcon 9 Heavy be a couple years. So if we launch Falcon 9 next year, about 2 years after that, we launch Falcon 9 Heavy with the kerosene upper stage, and probably, I guess, like 2 to 3 years after that. So about five-ish years from now is when we hope we'll have the cryogenic upper stage, the hydrogen upper stage. Although there's a lot of risk associated with that development because it's a very difficult stage to do. And we want to ensure that at least foundationally it's capable of a very reliable restart. And then we've got our Dragon spacecraft in development, which is what will replace the space shuttle after that retires in 2010. Initially for cargo transport to the station and cargo return to Earth. Although we designed it to require minimal changes, in fact almost no changes, to carry the crew, there's some additional hardware that needs to be built, in particular an escape tower, obviously seats, but that's relatively easy, and some enhancements to the life support system. We already have most of the life support system for the cargo version of Dragon, which we're required to carry biological cargo to the station and back. Mice and plants and things like that. And some of the hardware is quite sensitive, so we have to maintain temperature within a narrow range, humidity, and that kind of thing. So yeah, those things are sort of progressing. Not necessarily as fast as I would like, but we're certainly making progress, and we'll keep going until we ultimately have some ability to get to Mars, and not just get to Mars, but do so in a manner which is where there's some substantially better economics than has been predicted to date. And I think we ultimately need to get to a cost per person of around maybe $1 million or $2 million for a one-way ticket. The return tickets are much more expensive. It is money. I don't know. I guess probably 5 times easier, or maybe 4 times easier to just get a one-way than to do a return. And so if people are going to go there to settle, then hey, you don't need the return ticket. When people came over here from England in the beginning, I don't think they bought return tickets. So, but anyway, I think if we can get it down to a few $1 million, so if we can get some sort of point where the cost of a ticket to Mars is greater than, say, the average house price in California, or rather less than the average house price in California, then I think there's some number of people that will be willing to sell their house and all this stuff and go to Mars. At least enough to get things going. So.